Waking up the morning of climbing onto a rocket is an interesting feeling. There's no fear. There's a high degree of awareness, and everybody is concentrating and thinking about procedures. We have spent at this time about a year getting ready for this flight, and we were ready. Walking out, you see some friendly faces behind the cameras, which is always nice. Driving out to the pad, you notice the pad is deserted, and you're pretty much alone, but you know that there's a lot of people who are with you in spirit. You'll see the sparklers igniting to burn off the excess hydrogen here as the main engines ignite. Main engines ignite about 6 seconds prior to liftoff, and it's a very long 6 seconds because by this time your brain is working overtime. You'll see an interesting shot of the flame trench and all the water that is used to damp the acoustic vibrations during ascent so the vehicle is not damaged. Liftoff, as you watch from the ground, the vehicle appears to climb very slowly and stately, but I'll tell you there's nothing slow about it when you're sitting in the cockpit. The only two words that came to my mind, other than the technical operations of the vehicle, were speed and power. The vehicle has a tremendous amount of speed and tremendous power as you're climbing uphill. As the vehicle passes through the region of maximum dynamic pressure, it pitches and yaws into the relative wind, and we experienced oscillations that you can't see on the video here of about plus and minus 2 degrees per second. And that's an interesting feeling in itself. You can feel each and every one of the 7.5 million pounds of thrust, and when it starts moving around, it's pretty interesting.
Once we got up on orbit, we had an extremely clean vehicle, very minor problems. I think one heater had failed, very inconsequential. Quick tour of the payload bay. We had the USMP pallet with 2 major experiments, Mephisto, a French materials processing canister, and then from JPL and Stanford, Lambda Point, which was a helium experiment that they had very successful runs with. The attitude sensor package, which was 3 sensors provided by ESA to look at advanced spacecraft control and guidance systems. And then we swing around and look at the Canadian test article, which Steve and Lacey used for all the space vision system experiments. Lewis provided us a gas can with the tank pressure control experiment, which was a little fluid control effort. And of course we had the Canada arm, which Lacey, Steve, and Tammy used extensively in their series of runs. And of course in the back of the bus is the Iris Legio sunshield, and looks like we're getting ready to deploy here.
Yeah, here we are preparing to deploy the Iris Legio system on flight day 2. After the orbiter was maneuvered to the proper attitude, we opened the sunshield to reveal the spacecraft and the deployment system inside. All this was done against the backdrop of a beautiful sunrise, by the way. The satellite was spun up to 65 RPMs and then deployed out of the payload bay. With all its shimmering surfaces, Jim Weatherby commented it looked like R2-D2 coming out of the payload bay. You can see the shuttle provided a very stable platform for the deploys. It goes right up the line of the tail. The space shuttle system, of course, deployed the satellite into a 160 nautical mile orbit. And then there was a perigee kick motor on the Iris deployment system that placed the satellite into an elliptical transfer orbit. And subsequent to that, an apogee kick motor on the Legios itself fired to place the satellite into a 5,800 kilometer circularized orbit so it could then begin its scientific operations of mapping the Earth's surface gravity and looking for movement in tectonic plates.
Here's Biggs down on the middeck. He's just left his portable computer and he's looking at the Boeing furnace that we flew. Actually, it's 2 furnaces. I guess Lacey's making lunch there. But we're running the forward furnace. We've got 2 cameras set up, and Bakes is just doing some checkout there. The furnace processed cadmium telluride crystals, and we had 2 separate runs, 2 samples each. And basically, we talked to it with the computer that you see there.
Apart from the space vision system that I had a series of Canadian experiments that reflected our long-term plan, or portions of our long-term plan. Here is a phase partitioning experiment where we have 2 polymers, and you can liken that to oil and vinegar, and they tend to separate out in space. And it just so happens that healthy blood cells will go with one polymer, and unhealthy blood cells will go with the other polymer, and my job was to determine the resolution of that separation on space. We also had another experiment concerning materials degradation in low Earth orbit. We had 378 samples on the witness plates of the arm, and throughout the entire mission we exposed at night these samples to the ramjet direction. And many of these samples are or substitute samples that we plan to use on the mobile servicing system for space station, which will help to assemble space station. And another experiment that I had in the middeck is a small furnace from Queen's University that is about 8 inches on a side. It's a cubic furnace, but it can attain about 1,000 degrees C. And we were looking at the diffusion of one liquid metal into another liquid metal, and we were able to do about 40 samples throughout the course of the flight.
Another of the experiments we were operating in these very close quarters was the heat pipe performance experiment. There are 4 spinning heat pipes, and here we're adjusting the power input to those heat pipes. Along each of the heat pipes there are 8 temperature sensors that are read out on that display, and by looking at the time history of those temperature sensors we can determine how efficiently those heat pipes transport heat in microgravity. And Hughes is hoping that these data will allow them to reduce the weight and size of heat pipe system on commercial satellites.
Here we see Shep working, preparing to get into the LBNP, lower body negative pressure. This is one of many medical experiments that we did on board, mainly to look at extended duration orbiters and readaptation to 1G. We also used Florinef in one case, which is a drug to help you maintain water, and used the LBNP device to test the effects of that.
At least once per day we had a media event, and it was an interesting diversion to an otherwise busy day. We could put our books down and talk about what we were doing. They were kind of fun performing these interviews.
With a very busy schedule like this, during the flight we often barely had time to grab a bite to eat whenever and wherever we could find it. And a lot of our meals were just about like that during the course of the day as we were working on all these experiments. Watch the veteran Jim Weatherby keep his dish very close to his mouth while the rookie here, Steve McLean, plays with his food and nearly loses control of his granola and probably embarrasses his mom in the Steve, being a national champion gymnast, tried to instruct some of us in the art. He gave me a 2 on this particular maneuver. I was happy with it, though. And no post-flight movie would be complete without the famous floating juice drop. So we bring you Dr. Tamara Jernigan chasing tropical punch through space. Now you see it. Now you don't. Zero gravity makes some things easier to do, like passing computer disks around the middeck. And you just saw one fly out of a computer there. With Jim Weatherby on board, though, it's dangerous for anything that looks remotely edible to be floating around free like that. We conducted RMS ops. Tammy and I operated the robot arm on nearly every day for CanX to primarily SVS, and on flight day 10 we culminated that by deploying it. We didn't know how it was going to react when we released the snares in the end effector, and it turned out to be very, very stable, so pulling off of the grapple fixture was no problem. And from there on we flew proximity ops with it over the USD.
Yeah, the unique thing about this flight is it is the first time that we've used cameras to do station keeping operation. On orbit, we station kept at 150 feet, and when we had good video, we had good range data on the system. And so this was very, very exciting to do, watching the CTA station keeping with it and then departing with it.
That was the SEP-1 burn where we intentionally did not blast the target. You'll see here in a second, in preparation for space station rendezvous, we do intentionally blast the CTA with the braking jets. And there it is there to see the effect of the jets on the target. This was about a 1-second blast from 150 feet, and it will help us in the design of the space station and development and rendezvous for the space station when we analyze the data to see the effects of the blast. It's interesting, in proximity operations, our relative velocities are sometimes as low as a half an inch per second between the orbiter and the target. You'll get a feel for how fast we're going around the Earth in a second. Our relative velocity around the Earth is about 500,000 times faster than that. We passed overhead the CTA, and you see it down there moving in relation to the clouds. It was pretty exciting.
It's one of the most enjoyable things about spaceflight is being able to see the Earth from space, and we carry numerous cameras on board to document this. One of them is a Aeroflex 16 millimeter, and we have two on a dual bracket. You can see there is a Hasselblad 70 millimeter format camera. We carried a Linhof camera, which is a large format camera in addition to those. And they're standard 35 millimeter cameras, Nikon. In a minute you'll see, I think, one of the most beautiful spots in the world from space, which is the Bahamas, off the coast of Florida. We caught it here in the early morning with some sun glint. Coming up is one of my favorite shots. We were able to get a panoramic view of the U.S., entire U.S. coming from California across to Florida. Unfortunately, we ran out of film by the time we got to Florida. That trip takes us about 7.5 minutes. So since we didn't have enough time to show you that, this is about 6 times normal speed. And there you see California. You can see the Central Valley, the Sierra Nevadas. In the center of the picture now is the Salton Sea, Great Basin in the western U.S. Gulf of Baja down there in the lower corner left. It's amazing how far north you can see, and we'll illustrate that a little bit later too. Coming up on the right is White Sands. And to the left of White Sands, you can see the Rio Grande River. South of White Sands, El Paso. Now we're coming across Texas, looking north into New Mexico. Coming up, again, this is 6 times normal speed, which we had to do so you could see this entire clip. On the right, we'll be coming up Houston. You can see the river valleys in Texas. There you see Houston and the Galveston Bay. And the lower left now, coming across New Orleans, Lake Pontchartrain, the Mississippi River Delta there in the center of the picture now, Mobile Bay, and the Gulf Coast of Florida. And of course, that was kind of the route that we took for entry, and it took us right across the U.S. into the Gulf of Mexico, over to Florida, onto the Hack.
Handling qualities of the airplane are exceptional. It's really a beautiful airplane to fly. We had spent, both Mike and I had spent at least 8 years getting ready for this moment, and 1,000 approaches in the shuttle training airplane. You've heard all the bad things about the low lift-to-drag ratio and zero thrust and Elevon configured vehicle with reverse flight path sensing. But if the task is not complicated by bad weather, it is a beautiful flying airplane. It was well worth the wait to get a chance to land the vehicle. After we touched down, we rolled out for several more seconds. When we got to our derotation speed, Mike actuated the drag chute, and you'll see that come out as we initiate derotation. The drag chute, I think, is a good system. I was happy to deploy it. Both Mike and I had worked on the development of the drag chute system for several years. It did pull to the right almost exactly the way that it pulled on Hoot on the last mission, but for me it was nothing unexpected. They had showed me what it might feel like in the simulator pre-launch, and it was exactly the way they had showed it. And then at about 60 knots, Mike jettisons the chute. And then we roll to a stop with very little braking. I think the system is a good one, and it will help us someday if we ever do have any problems with tires or blown tires or brake problems.